Hello everyone, my name is Mbohala Namaga, student Makerere University, offering a bachelor's degree of science in software engineering. Today we are going to have an interesting topic, um, the exposure of artificial intelligence to the community. But my project is going to deal with the artificial intelligence in the transport sector. Don't forget to subscribe, like, and share. So, as I've told you, the topic is the exposure of artificial intelligence to the community. What's artificial intelligence? Artificial intelligence is the can be referred to as the systems that mimic human behavior. So mimicking the human behavior, they perform different tasks. So the problem description, we first of all have the poor transportation. The poor transportation of services. These services are required. Transport services are required since roads connect people to goods and services in time. Okay, not only roads, but different means of transport. They connect people to goods and services. And we also have the reason why the community has to know about this. We have transport congestion. So in case applications are built, which I want to do because I want to design an application for booking and ordering public transport like taxis. So this congestion will be reduced since people will know that this and this has traffic jam. This and this at this time and this time this car is moving. So you're able to know. And the other reason for public transport. So it will be made safer and easily accessible by people in that you order, you know the time, and there are different biometrics going to be introduced. The voice recognition, whereby you have to know what has occurred within the distance moved. So you're able to know the voice recognition, the voice recordings, different things, the biometrics taken. So I repeat, so you're able to know what's happening during the way. So we have the how artificial intelligence, how is it going to be applied to solve poor transportation? So first of all, the mobile apps. This we already know because you're exposed to some mobile apps for motorcycles. And we have the drones for delivering goods. This is the best thing because it reduces the human errors. It's very fast, and as you know, aviation is the safest mode of transport, so it will be very good. And machine language, it can predict traffic jam. That's what I was telling you, reducing the congestion. So we have the types of data that will be used to solve that transportation. So we have the image data, we have the facial recognition, which is going to know which customer, which driver. We have the text data, which is going to know the contracts, the messages texted within the car, anything, the sound, the voice recording, things I was talking about. So we also have the computer vision. This one enables to collect the image data, text data, sound data, and we get meaningful information. We take actions and make the recommendation on the above information. So we have the differences between supervised and unsupervised learning. Supervised learning, it's all about labeled data, and so both supervised and unsupervised are both labeled data and labeled data. So we can get to know the differences. And as you see, we have many differences. So we have, this is what I was telling you, for supervised learning, the training dataset is labeled, unlike the unsupervised. And this supervised learning is very complex, unlike the unsupervised, which is less computational, because this one, the supervised learning, making it very hard is that it has a lot of computation. So we also have this difference. Supervised learning uses offline analysis, while unsupervised learning uses real time. So what we mean, like real time systems, we all know we've been exposed to different things. Like for example, in the hospitals, we know like such instruments that need real time data, like, because here we're dealing with people's lives. In case of any bias in data, that's going to lead a very, very, like, a lot of losses, which we can't responsibility for. So the numbers of classes are known in supervised learning, unlike the unsupervised learning. And we always have the very last one, we always have accurate results in supervised learning, unlike the unsupervised learning. So just in case, I'm going to further explain the supervised and unsupervised learning in my next video. So just in case you need to know about it, don't forget to look up, subscribe, and then further know what everything required on this. So we also have this, the mode of distribution of data in order to learn more. So yeah, since the data is not labeled, so it always diversifies and discovers how to present the structure of its data, because data isn't labeled. As I was still explaining, the supervised learning techniques that will be used in solving the problem. We have classification, multiple classification, and we have the neural networks. So for classification, it involves grouping data into classes. So you're able to credit a driver, but you're not going to credit a driver, like two drivers, for example, they're having, for example, one of them is a tax default and another one is not. So you're not going to give them the same salary. So we have the multiple classification, whereby you're going to give differences. Is this a short-term passenger, a historical passenger, a long-term passenger? So you're able to spot that with multiple classification. And for neural networks, these neural networks, they are just algorithms designed, like, so for example, the data will input different data like sensory data, resources, and we can also use the black box algorithm. I'll further explain that in my next video. So we also have the unsupervised learning techniques that will be used in solving the problem. So we have different techniques. We have clustering, we have association rules, we have principal component analysis. So due to time, I'll explain the principal component analysis. So for the principal component analysis, it's about the okay, for example, we have a lot of data, because we can have different type of data. We have the voice, we have text, we have image. So we compress that data set into so we're using the extraction feature. So we'll create a new data presentation, yeah, which yields to principal components, data that is easily accessible and does not give a very hard time to analyze it. So we can further, like, we have, by default, no, a project can't exist without any challenges. So because of the different aspects, you never know during operation, during what, you never know. So we always have lack of trust and deliverability, and then this is going to be evidenced, like, sometimes, because not everyone is going to have to believe in you that you can. So we have the cost of training. Since this is a new system, people are not aware of it, you have to train different people to learn. So, and the difficulty in accessing vendors, not everyone knows some clue about artificial intelligence, so you're not going to be able to make people believe, but at least you should increase the bravery and flexibility so that make people believe, and lack of business integration. So whereby you never know, as the impacts increase, the profits increase, you need to integrate, but sometimes it's hard, because even the existing AI might be a problem, like people failing to learn it at a faster rate. So we also have the possible solutions to the previous problems, like lack of trust to increase the degree of bravery and flexibility. And we have the costs on training. As I told you, we need to teach both the people like on higher level, lower level, to teach them how the system is working, and the difficulty in accessing vendors. Like what you should do, you should always know what. Learn to explain people why and where do they need to use the artificial intelligence. So, because you're not just going to come and bump into people and then you're like, you need to use this, you need to use this. So, and the lack of integration, you should have planned the operation properly because you now know what next, you now know what are the profits, you now know. So, we have another thing. It's about the difference of accuracy, recall, precision, and FI score. So, the F1 score um, is the major rule. And F1 score, I should know because it's always precision, recall, accuracy, F1 score. Well, but F1 score is always more accurate than accuracy. So this making it the most relevant. So precision, recall, accuracy are the three metrics that are used to measure the performance of machine learning algorithms. So we use them to measure performance. That's why they into existence. So accuracy, as we said, accuracy it deals with the ratio of correct predictions and we it's the ratio of correct predictions and other predictions made by an algorithm, or it can be calculated by precision or by recall. So for the F1 score becomes 1 only if the precision and recall are both 1. So for the F1 score becomes high, like only when the precision and recall are high. So they are related. If this one is high, the other has to be high. So we also have F1 score is a harmonic mean of precision and recall and is better. So we have the two most appropriate artificial intelligence evaluation metrics for your project. Yeah. So first of all, it's the clever of understanding the project. When you understand the project, you always know what's next. You always know what are the profits. You always know what's your next step. Like you always sure. You can't give 100% correct results, but at least you give something good. And so this is what I was explaining. This will extremely be important for business. You also have the turning the impact levels into cash. You're not going to suffer with your code, like everything, when machine learning, what, and then so you have to get means to calculate the profit and know how you're earning, what you're losing. You know that these were my most relevant references. And so, and thanks for listening. Don't forget to like, share, and subscribe.